So again, I'm at SRP. I'm in our grid planning performance group. Our group does both the planning and the monitoring and reporting on the performance of our system. So I'm on the planning side. Right now, when we do our analysis and synergy, we're just looking at our peak load. I think that's what a lot of utilities do. So this presentation is how are we enhancing the synergy model, so once we do get those load profiles, we're able to do the 8760 analysis. So first I'll give a little overview of SRP. What was the opportunity? What is the problem we're trying to solve? Our goal, what do we want to accomplish? Talk about the synergy model with automatic, also known as switch capacitors. What was my experiment? Conclusions, next steps. Whoops. I had it in the wrong place. So this SRP's territory. This part right here is our service territory. This is the reason we show this part here. So this green part, we serve about the greater Phoenix area. There are some pockets that are served by APS. We have approximately 2,900 square miles that we serve. Out here in this area, we have the mining area. In the mines, we serve the mines. The commercial, residential people are served by APS, but we serve the mines. Here's some statistics of our distribution system. With the exception of the customers, everything is actually modeled in Synergy. The customers, we don't actually model individual customers, although the peak load from the customers are modeled. Oops. So right now, again, our Synergy model, we just have peak load, and that's fine for now because our main purpose of using Synergy is in the development of our 6-year substation plan. However, and because of that, our capacitors are in manual mode, and being that our peak is summer peak, our capacitors are always on, so they're always connected. However, as more and more people are putting DER on their system, also we want to be able to do off-peak analysis, do the 8760, 576. We need to enhance our synergy model, so instead of being static, it has to be dynamic. And one of that things is we need to model our capacitors in automatic or switch mode. So we broke this goal into 2 parts. One, fiscal year 19. So in SRP, our fiscal year is May through April. Last fiscal year, it was proof of concept. Does this work? So we only picked 3 substation transformers, and we had to manually install all of the data. We were able to prove that it worked. That's what I'm going to show in this presentation. So the next step is to create an automated process so I won't have to manually, program every single capacitor, because as you saw, we have over 3,000 capacitor banks, and start installing it. So every year we do a synergy model build, and we want to include this in that model build. So for my experiment, I created 3 models. Again, 3 substation bays picked throughout our territory. They were picked in conjunction with our capacitor tech. So we tried to pick bays that we had capacitors of various size. And so I create my base model. My base model is pretty much the model that we're using now. Just look at peak load. Then we created one with automated transformers without voltage override. And without voltage override, what this allows me to do is see the model I'm creating. Do the capacitors turn on and off in the order that I programmed them? Then the third model with voltage override is, if there's a voltage issue, will it forget about the sequence I programmed and go ahead and turn on or off? Now, at SRP, we use our capacitors the main purpose of our capacitors is to maintain a power factor of unity at the substation. So right here, this is the, let's see, this right here, allows us to define the caps. So as you see, my control is substation kVAR. Now, when it was a manual, we put the values here, but since we're doing automatic, I put the values right here in the switch model. This is per phase, so for 600 kVAR cap, I would have 200 here. We close at 70% of if we have a kVAR reading of 70%, and we trip at 45% of the cap banks. Also, the sequence. Our sequences of the order of operation for our capacitors is at the capacitor, at the substation level. So in other words, if we have 4 feeders connected to the substation, all the capacitors on those 4 feeders are part of the same sequence. If we have 5 feeders on the substation transformer, the cap banks on all 5 feeders are in the same sequence. Also here, just right here is, one without voltage override, that's not checked. The ones with voltage override, that was checked. So the purpose of my study, as I've already stated, was 1, will the capacitors turn on or off in the sequence that we programmed them? 2, if there's a voltage issue, will the capacitor turn on or off in order to maintain that unity power factor at the substation? So because I don't have, because our model only has peak load, because we don't have those load profiles, I had to, in a sense, force it out of range, my load, change my loads. And Synergy, if for those not aware, there's a scale manager. So by scaling, I'm able to change my load. So the spot load at SRP, we have our distribution load and the spot load. So in order to test, is it doing, are the capacitors going to turn on or off in the order that we want, I modified my spot loads. So right here, I added 25%, 50%, 75%, and 100% of spot load. Then the second, when I was trying to test, will they, with voltage override, will override the sequence, then I modified the voltage. So I did 0.9, 0.95, 1, 1.5, and 1.1 of nominal. In order to verify that this is doing work, I was looking at both the substation power factor and the order of the capacitors that they turn on or off. Now, before I go into my results, there were some limitations. For each capacitor, we could connect it to a bay, substation bay, we could only do one sequence. Now, for most of our capacitors out in the field, that's fine, because the capacitors out in the field and the capacitor banks inside the substation are part of the same sequence. But there are a few substation bays in SRP territory where the capacitors inside the substation are on a different sequence. At this time, Synergy does not allow you to have 2 sequences for capacitors connected to the same substation bay transformer. Also, for this model, you could only use 1 trip close criteria. So again, we were basing it on substation kVAR. That's fine for the capacitors out in the field, but the capacitors in the substation, actually, there's 2 criteria that need to be met in order for them to operate. Not only do you need to, does the kVAR have to be out of range, but you have to have a certain amount of a percentage of load on that transformer for them to work. We have been talking to Synergy, and I know in the future versions of Synergy will allow you to have more than 1 trip close criteria. So we have been working with Synergy to address this limitation. So ran my model. This is with the voltage override. What I'm trying to see again, does it result in a unity power factor at the substation? So I compared both manual, where in manual all the capacitor bays are on. As you can see, as you lower your peak, my power factor gets pretty bad, moves away from unity. But once the model that included automated switch capacitors, you notice that my substation power factor is close to unity. So this shows that the model does produce a substation power factor unity. Now the next part was, well, did they turn on or off in the correct sequence? So that's what this is. In the ideal, if this was working exactly how we would want it, it would be all a group of closed followed by trip, which it does for 75% load, 50% load, 25% load. For the baseline, you do see that this one was tripped, and again, we were expecting it to be closed. So we did some investigation, and what I found is this capacitor is a 900 kVAR cap. This one's a 1200 cap. So this one was closed, then closed, and then when it got to the fifth one, it had 5 closed, but it still needed between 0 and 300 kVAR in order to get that unity. So what it did is it turned off the 900 and turned on the 1200 to give us a, just need that 300. So if you take the 1200 minus 900, you get a 300. So that's why this one turned off, that one turned on. Now in reality, in our territory, that one happened. The one would have stayed closed and 6 was closed. So again, a limitation of the experiment, but overall it worked the way we want. So we feel confident with this model. So the next study was to see, now if I enable voltage override, will the voltage override the sequence and turn on or off? So again, I did the analysis, with, and in this case, they're both the automatic, the switch capacitors. This has no voltage override, and this has voltage override. Well, you notice that in both cases, you get unity power factor, which makes sense because in the previous slide, I just showed that once you use switch capacitors, you do get unity power factor at the substation. So this doesn't really tell me, it tells me, I get the unity power factor, but I still don't know, is it voltage override happening or not? So my next slide is, this is with, no voltage override. Again, I would expected all these to be closed. This trip is the same reason as before in terms of we had a 600 and we only needed 600 more, so it closed that one open to 1200. I did investigate why that was a trip instead of closed, and I'll be honest, I forgot why this was tripped instead of closed. But you see with voltage override that it does override the sequence, and you have random closed and tripped. So what this tells me is voltage override does work on the system. So conclusions was that the model with the automatic transfer capacitor both were tripping close as programmed. That, let's see, that they do part of the sequence, and that we're able to move to phase 2. So again, this presentation wasn't so much, we haven't really done any analysis yet. It's more, we want to get our model ready, so once we do get those load profiles, we're working with loads here, and hopefully by the end of the year we'll get some load profiles. So once we get this model, our synergy model ready for us to do 8760, then we put those load profiles in, we'll be able to use it. So our next steps are, we're going to develop a process to automatically pull the capacitor data from our voltage management system. Again, this experiment, three substation base, about 45 capacitors. I manually put in the values. I manually put in the sequence, which is fine for 45, but you saw we have over 3,000 capacitor bases. It's not realistic to do that manually. So I've been working with our cap techs, our distribution operations center, in order to get that data electronically in the format that we need. And then now, once we get it, we do one main synergy model build per year. And so we're planning to get this data prior to our next model build so that we can incorporate it into our next model build. And that, yes.
So it sounds like you're very close to having a modeling convention you're comfortable with
Yeah.
technologies, not just deep, but install sequence.
Right.
Load model scenarios.
Yes.
Are you planning on using this to then do some sort of other study to optimally place or adjust your capacitor mix to more evenly control that power factor stuff throughout the year? These different scenarios, or what's your end game?
So that is one thing we are looking at. I guess the main thing we're looking at is how both PV and also electric vehicles energy storage. It's more the DR that we're looking at. However, we will start and we will also use it to optimally place our capacitors. One thing I forgot to mention is on one of the slides where I was comparing the one where all the capacitors are in manual mode. If you look at load 100%, not all of them were turned on. I mean, I'm sorry, when it's automatic, not all of them were turned on at load, which tells me that we do have capacitors out there currently on our system that we don't need, that they're not optimally placed. So yeah, placement of capacitor. Quick answer: yes, we will use it for this, but that's more like a side benefit rather than the main reason. Any other questions? Yes. Oh no, we're not. That was just for that. That was for the study. I mean, I guess what I'm saying in our when we do our study right now in our model, we just turn them all on. But yeah, you're right. In the field, they're not all turned on. In fact, when I actually do a capacitor study every year, and I'll say, oh, I need, based on my study, I'm assuming they're all on. So I'll say, oh, I need a capacitor there. And then I go to cap techs and they'll verify. Sometimes they come back and like, oh, that cap, we already have cap 8 there. It was turned off. So I don't need a new cap there. They just need to turn that one on. So yeah, it's only in the model that we have everything turned on. Do you want to add anything, Ken? Okay. Ken Brown's the one that actually does the model build. So anything else? Cool. Thank you.
Thank you.